Okay, so I'm going to tell you a little about generic problem solving techniques. Although I'm an undergraduate student in mathematics, you spend a lot of time solving problems. Actually, you find in the business world there are many problems that are not strictly in the same kind of structure that you have in a standard maths class, where you see you have to differentiate something or integrate something or solve some equation. They're probably more interested in problems like how do I double my profits? How do I make my costs 20% lower? And there are actually techniques available to kind of solve problems like this, or at least structures to show ways to solve this in a more convenient way. And these are problems of business. If you want to increase your profits, these are the problems you're interested in because they're the ones that help your company grow. And if profit's not growing, it's how the business doesn't go bust. And obviously, when job adverts, they ask for kind of some technical skills, but they often ask for candidates with good problem-solving skills. So this is a kind of introduction to some of the ideas. So I'm going to give you a kind of generic introduction of problem-solving, and then sort of like 30% into the podcast, I'm going to talk a little about a kind of generic framework taken from what management consultants do when they go into a company and try and fix some problems. Okay, so what kind of problems we talk about? So if you're working at a large housing association, how do you make sure there's enough electricians available to make repairs in houses owned by the association? Maybe you work in a startup. This is example 2. Your team builds a cool app involving a chatbot, maybe to help people with mental health issues. But obviously for your company, as revenue comes from people paying to download the app from the App Store. So how do you encourage more people to actually download the app so your company makes money? Example 3, if you're delivering fresh food in the local area from Plymouth, from local farms to houses, how will your company continue to grow as Amazon and other shopping markets also start do home deliveries? What's your kind of strategy? And even if you're not in kind of business, if you're a maths teacher and there are only 4 students taking further maths at A level, the head of school just might say, well, that's not enough. So unless more students sign up for the further maths course at A level, we're not going to, our school is not going to hold that. It's just not cost effective. And then if you really want to teach further maths, you have to think of a way to increase the number of students taking the class. And that's also a kind of generic problem solving skill. It's not. Okay, so people study, so there are ways to solve problems, and then people study kind of generic problem solving skills. So why do they do that? Well, obviously one of the reasons they do that is to actually get better at solving problems. Obviously we all get paid to solve problems, so the more efficient we are at it, the better we're viewed as an employee. A particularly important idea in this problem solving is transference, which is skills in solving problems from one domain can help solve problems in another domain. So if I'm doing some kind of calculations in physics, and then there are similar equations for an application in business, that there's some kind of impact, I can use this, then there's good transference, then I can solve a larger set of problems, essentially. And another thing that people do about solving problems, a kind of just generic thing, is we're thinking about better ways of solving problems. So some people like to say they like to reflect. They've solved a problem, they like to reflect on it, or just think about the methods used to solve a specific problem. And then this will help build up a kind of toolkit of ways to solve problems. If you just, after you solve the problem, you look at it again and say what things worked, what things didn't work. And this is sometimes also known as metacognition, which is thinking about thinking. Another thing you might want to look at, so we're talking about why do you want to study ways of problem solving. One way, it's also important if you want to teach mathematical techniques. Typically, many times we present examples, different examples, and then kind of hope by osmosis that people will pick up what the general technique is. But somehow, if you could teach more generic techniques of problem solving, it might help students learn mathematics or some other subject better. I have one slide later on. So one of the things that the psychologists, they're interested in problem solving because it gives them insight into the way the mind works. Just the kind of, what kind of hardware you have and what kind of software you have in your mind, the way you kind of approach solving problems, it gives you some insight into that. And also people try to use artificial intelligence down here at the bottom. So you can in the past people tried to study the way that problems were solved by experts, and then they could use that information to try and solve, to try and code those things up with an artificial intelligence. Okay, so problem solving mathematics, I just want to give a bit of context. There's a famous book by George Pollock called How to Solve It, and in this book he describes methods to develop mathematical arguments, how to develop proofs and solve things. And essentially it has heuristic strategies to sort of getting strategies for solving problems. So it has 4 generic rules. So it sort of has, first you have to do is understand the problem. Then you're given some kind of mathematics problem. Then you try and use your experience from related problems to plan an attack. And attack just means the strategy to solve the problem. So you might try a couple of different ideas, some work, some don't. Then you actually carry out the attack, which means actually try and solve the problem. And then he has at the end, you should check the answer. And his book I was just reading, he also says as well, is when you've solved a problem, it's also good practice to look back at the solution and think, well, could I have solved things more efficiently, or are there any kind of generic lessons I learned from this example? Okay, so just one problem in one slide on psychology. So if you look in a book on psychology, particularly say cognitive psychology, which is the study of the mind, they'll have like a chapter on a discussion of how humans and animals solve problems. And the kind of things they're interested in, what's the difference between, say, an expert when it comes to problem solving, what's the difference between an expert and a novice when it comes to problem solving. For example, what is the difference between the way a grandmaster plays chess and a beginner plays chess? And they've also, in the past, there should be something called behaviorism, and there they were interested in, they thought they could use simplified models like animals and look at mice going through mazes and try and study the way that these animals solve problems to give insight into the way the humans solve problems. And they also have this kind of abstract ideas. So that part of the reason they're doing it is partly to understand humans, but also how to do things with artificial intelligence. And they have a kind of abstract way of problems where there's a big solution space. And then solving a problem is actually applying some rules on the solution space to move towards the solution. This is a bit kind of abstract for us. More practically, there are things called management consultants, and what these do, this will be a company, this will be a team of people, and if, say, a firm has some issues, they want to change the way they do business processes, or they want to just increase their profits or reduce their costs, they might bring in a management consultancy firm. He'll bring in some experts who'll look at various parts of the firm, and then they'll make recommendations. McKinsey is a famous firm of management consultants. You can see here the Wikipedia page. So as preparation for this, I did read the book called The McKinsey Way, Using the Techniques of the World's Top Strategic Consultants to Help You in your Business. So this was a guy who used to work for McKinsey for a while. It was very kind of high pressure environments. As far as I can tell, people just work there for a couple of years before they burn out. Well, not burn out, they move on to other things. And he was telling us things of what happened. They have these consultants, they go in, and they just have a kind of structured way to solve business problems. And they also have ways of remembering information to help to be efficient at doing, because that's what their business model is. They get paid to solve problems for businesses. So I'm going to tell you the kind of the problem solving techniques, which is sort of a slightly simplified version of what was in the book. And this is you'll see this in other places as well. Okay, so here we're looking at kind of generic problems, not really just mathematics, but just problems like how do we increase the profits by 20%. Okay, so the first step they'd have is define the problem. You may be asked to solve a problem, but the actual statement may be very vague. As I say, how do you increase the profits by 20%? It doesn't tell you if you're making a number of different goods. It doesn't really tell you. It's not too informative. So sometimes it kind of helps to reformulate the problem to actually state it correctly. And then what they do, they'd also do a kind of research phase. I mean, not just look online. They'd have internal sources and documents, and they learn about some of the business and some of the problems. So for us, this has to be looking online, looking on some things. And then, so once you have a bit of, then you have some background information when you've done your research. And the next idea is to write down some possible solutions. And so here they do an idea just called brainstorming. And so everybody sort of has probably met this before. But essentially you just write down as many ideas as you can to solve the problem. You just write them on the whiteboard. There's no censorship at this stage. Even if an idea is completely crazy, you just go, okay, fine, let's put it on the list. And no one's meant to say, oh, God, that's completely stupid. You shouldn't even think about that. It just goes on the list. Okay, and then the next stage you have is define a hypothesis, but it perhaps is better is evaluate some of the ideas in the brainstorming. And here you define a hypothesis means can you see a good solution, or can you see a way of curing the business problem? And you get that from the kind of research in the brainstorming session. And then obviously the idea is problem solving. So once we have a hypothesis or some ideas, we develop a plan, so a set of steps, how to solve the problem. And then even if we have a plan, at the end we still need to actually evaluate whether it's working. So we need to develop methods to check whether the plan's working. So what can be measured? So if we're doing something simple like this, if the idea is just to do something like how do you increase the profits by 20%, you'd have to put in some metrics to the plan of do the profits increase when you make these changes. Okay, so I should say this is sort of part of the plan as well. So this is you kind of plan to check whether the plan is working, and because we're not going to get to the actual implementation phase. Okay, so let's do a kind of generic problem solving. Let's do an example. So maybe a few years ago, well, maybe it's more than that, there was a lot of newspaper articles because employees at various tax offices or government offices were accidentally leaving memory sticks on trains. And these memory sticks contain sensitive information about taxpayers. And this generated a number of negative news articles. So if you're working in an organization, you might you say, well, we're getting all this negative publicity and people are complaining. We need to stop doing that. How do we actually stop employees leaving memory sticks on trains? I mean, it's not obvious how to do this. So it's kind of useful to have a kind of framework to do this, just some way to kind of structure the kind of problem solving. So this is going to be our example where we applied their methods in the previous slide. So one of the things we do is definition of the problem. And that's really how do we stop civil servants in the tax office losing memory sticks containing sensitive information. If you do a bit of background research, so I've just done a couple of links here. You could, if you're doing on things, you could read a report and stuff. So this first thing, well, you can click on the slides on the DLE, which I make available. So this guy here is like a forum, and he's lost some memory sticks. I mean, he's just losing some of his study aids, and some people suggest, well, if you put the USB memory stick onto your key ring, that'll stop you. That'll make sure, because the memory stick is with the keys, it'll make sure you don't lose it. These two articles below are about that actually businesses are losing a lot of money. They don't really have any good solutions because people are using USB memory sticks. And then this one down the bottom is hostile slammed because somebody lost a memory stick on public transport somewhere, or lost it and had sensitive patient data, so people are pretty upset by that. Neither of these two give kind of solutions, but they do show that it's a big generic problem. Okay, so we've defined the problem. So now we do some brainstorming. So the idea is we just write down any suggested solutions. There's no censorship, so you just write down anything your team writes down, and then you just want to generate a bunch of ideas, and then after that there'll be a kind of selection thinking about it. So one thing you do is people losing memory sticks, you can write an angry email to your staff to say you've been very naughty. Some people have been very naughty and they've lost memory sticks. Please don't do it again. You could organise a staff meeting, shout at the staff and say, you're all incompetent. Who are these people losing your USB sticks? You're making me look stupid. You could use some of the ideas from research and say, make sure if you do use a memory stick with confidential information, make sure it's attached to your keys, so it's less likely to lose it. Okay, you can say, well, get the staff to memorize any information they need to take out using memory tricks. Okay, so I think this is I view this as a kind of crazy idea, but it's okay to include it because it might suggest something else. I mean, it's probably completely impractical for somebody to memorize an entire spreadsheet, but it's what I suggested, so it's gone on the ideas. You could organise some training videos about security of data just to remind people. This is what at the university we always have lots of kind of training videos we have to do every so often. We get told off we don't do. You could make sure the staff only use encrypted memory sticks. Then if they lose it, it's not such a big deal. No one can actually hack it. More radically, perhaps you could pay for staff to have mobile broadband. In that sense, if they can access their the databases at their office, they wouldn't need a memory stick, and that might be more secure. But then you also might just want to say, well, we need to find out why the staff need access to tax data outside their office. Why are they actually doing work on trains and things? That might help us find a solution. Okay, so that's brainstorming. So as I say, you should be no censorship. You should just write down ideas. You shouldn't, if somebody writes down an idea, somebody shouldn't say, oh, well, that's kind of stupid. Why are you doing that? You should just write the idea down. There's no censorship. Okay, and then define a hypothesis or so I have hypothesis. Civil servants need their data outside their office when they are consulting with firms. It could be they're visiting a firm and they're kind of negotiating over their tax bills. And it could also be that they don't necessarily need the data on the memory stick, but they do need access to the records. So now we get to develop a plan. So we had some ideas, and now we have to do some kind of evaluation to see what the sensible plan is. Okay, I've actually broken this down into two plans. Normally you might just have one, but when I first heard about this, I thought, why don't you just use mobile broadband? But plan A is make sure if a civil servant needs tax data outside the office, they use encrypted memory sticks. Then if it is lost, no one can access. And then develop some training videos about the safe use of memory sticks. So this is a fairly cheap. You have to create some videos, buy everybody encrypted memory sticks, and do some training. Plan B would be to have mobile broadband access for staff and access data outside the office. Then there's also could be additional issues, like if people can then log into the tax office's databases outside, there'd be more kind of security issues. So you want to check onto that. And also it's going to be kind of expensive. It could be £20 a day, an individual plan. So it could be quite expensive to pay for broadband roaming charges to people who have unlimited data. And so it could be you need to develop an operation research model to estimate the cost of providing mobile broadband and the cost of additional security measures. And I think plan B would all be best, but it could also be very, very expensive just because you have to develop security, you have to pay for mobile broadband for all the kind of travelling staff members. So you might need to do a kind of operation research model to estimate the cost of that. Okay, then the final step was evaluate the plan. So we had a plan, had some options, and we need to show whether the plan is working. So we're not actually in this thing, we're not actually following the implementation. As part of the plan, we have a kind of evaluation stage. So one thing you might do is say keep statistics of how many memory sticks are actually being lost. It'd be also kind of useful to understand a plan for this, how often data is transferred to a memory stick. I mean, perhaps it's possible to measure this and count, and then you can do some statistics. And then if the broadband option is tried, perhaps some people just don't like using it or it's too slow, and it'd be kind of useful to find out actually how much time the staff are actually using this kind of option to access data if they're off-site. And also, you'll perhaps also send a questionnaire to staff to find out why they need to put data on a memory stick. Okay, so this is the summary of kind of the memory stick example. So the final thing was the last thing we had to do. We had a plan, and then we had a kind of evaluation of the plan. So the loss of memory sticks to confidential information is a costly problem for companies and the government. The final solution doesn't involve mathematics. It's a kind of mixture of ideas and kind of sociology. I mean, it's not clear that just shouting at people would really do much good. But at the end of the day, if government agency is getting negative press about memory sticks with sensitive information on, it's kind of a big problem and it needs to be solved. However, some parts of problem solving involve the application of mathematics. So for example, I said that using mobile broadband would be that's a very good solution, but there are some security issues. But also, it's also going to be kind of quite expensive if you had to provide kind of unlimited data for 2,000 staff every month. So here's what you use in mathematics to do kind of operational research to kind of study if it's cost effective to do that, and also has some things you probably want to build in from statistics. If you're evaluating is how many times people actually load up memory sticks and take data out, and that will give you a better idea of whether the solution's working. And this is all true. So although some of these issues like this memory stick it's not just a mathematics problem. You can't just write down a partial differential equation to solve the problem. It involves some other skills. You are involving some kind of mathematics, and other problems could use kind of mathematical modelling or sort of back of the envelope estimates if you want to estimate, roughly how many people are doing this or that or what's been happening. So all these things are kind of math skills. So they're an important component part of this kind of problem solving. They're just not the whole part. Okay, so I gave you a bit of overview, very broad overview of problem solving in kind of mathematics, talking the work of Polya, and just one slide on how, like psychology, there's some kind of generic problem solvings, and there are systematic techniques to solve kind of business-related problems. I mean, there's no guarantee that these generic techniques will succeed, but it does give you a framework, at least to track these things more systematically. And also, if you go back, so I said we have in our kind of generic thing, our generic plan, define the problem, do some research, brainstorm, define hypothesis, and then develop a better check if the plan is working. If we go back to the slide on Polya's way how to solve mathematics problems, actually some of the techniques used in mathematics are similar. Polya had the idea of defining the problem and defining a plan, carrying out the plan, and then he had also an evaluation stage. So actually overall the kind of generic problem solving skills and Polya's kind of heuristic ways of solving mathematics problems are actually kind of fairly broadly similar. But at the end of the day, a business, if somebody wants to increase their profits or has some problems to do, it'll involve a mixture of mathematics and non-mathematics stuff. The problem still needs to be solved. And so the slides will also be available. So I have just a few links on generic problem solving and a little bit about the book, kind of an executive Wikipedia summary of Polya's work on how to solve it.